looking at establishing a relationship between inertia and mass. So the experiment is to do with mass of an object is a measure of its inertia. This is what we are trying to figure out. The procedure is quite simple. There are two cases. I'll handle case by case. The first case is to lift objects of different mass using spring balance. So what is this spring balance? It's this, it's like a hook structure. So it has a spring inside. That's your spring balance. So this spring, right, it shows how much weight a particular thing has up to a certain limit. So using this, we will try to figure out how difficult it is for lifting, see this heavier object compared to this. This is lighter, this is heavier. So what is that we are looking at, how difficult it is. So that's what we are trying to figure out. So we observe the amount of force required in each case, right? So let's have a look. So we'll start off with case 1. So let's have a look over here. Look at this video. Oh yeah, by the way, you guys have to figure out how much the spring balance comes down. Does it come and stop in the middle and go back? Or what is the maximum that it comes down, That's what we have to observe. Okay, reading is kind of difficult and I've not done a good job in capturing this. So you guys just figure out till what extent it comes down. Okay, so please have a look at this video. It came out till here, is it not? Almost till the bottom, right? Next, look at this scenario wherein you have a lighter object. It came out almost till the half, less than half to be frank. Okay, next, case 2. We'll make our conclusion after seeing the case 2. Here what we are trying to do is we are letting go of the weights from a particular height and seeing to what extent it gets this two things to rest. To what extent the spring goes down so that it gets this two to rest, right? So again, we're trying to look at how below or how down this goes. Again, don't try to read any readings over here. We just have to tell if it's half or 3/4 or full or whatever you observe. Please have a look at this. So I think it was 3/4, is it not? I don't know if you've seen a bit more. I feel it's 3/4. I saw it till 3/4. The next one, the lighter weight. So this is heavier and this is lighter. Please have a look at this. So we could see that it came out till 1/4. So what did we observe? Our observation is this. Object with heavier mass needs more force to make it start moving, if not get it to stop, right? Here we were trying to get it to move. It was just sitting idle. It was at rest. And in case 2, we let go of the mass. Means it started moving. The spring balance had to stop it. So in both of this case, we are looking at rest right? In this case, we are looking at motion. In both of this case, we are looking at inertia of rest and inertia of motion. We're looking at inertia. Here it's inertia of rest and here it's inertia of motion. How inert this is, how lazy this is. The heavier object is laziest. The lighter one is not so lazy. And when it comes to motion, the heavier object needs more force to be, force on it to be stopped, while the lighter one does not need. So what can we conclude with all of this? We can conclude that object with higher mass has more inertia of rest and motion. Okay, so if your mass is high, you have more inertia. That's the whole idea. So there is a relationship, and the relationship is they are directly proportional to each other. If I increase the mass, the inertia increases. If an object is said to have more inertia, means it has more mass. Right? So it has to do with both rest and motion. Okay, so please pause. You have to write this down and do draw a diagram depicting this or make your own conclusion. Whatever is convenient, but make this point.